Okay, I think we can get started. So good afternoon, everyone. Welcome to the third webinar of our P2 webinar series. My name is Chris Brazil. I'm a pollution prevention specialist at K-State's PPI.
I'm Jacob Larson, also pollution prevention specialist, PPI. I've been here for about 3 years.
Yeah. So our focus today will be on, oops, there you go. Will be on chemical processors, green chemistry, and P2 ideas to go with this industry. So for our agenda today, we will focus on a little bit of who we are, our current initiatives, some pollution prevention strategies, and Jacob is going to do a great job tying those into some of the compliance benefits that some of these P2 projects could contribute. And then at the end, we're going to have a Q&A. So feel free to ask questions during the presentation in the chat. And at the end, if you want to unmute yourself and ask some questions, feel free to do so. So our institute was founded in 1989. So we are part of the College of Engineering, the Engineering Extension Department. Our program is 100% grant funded. We are currently being funded by the EPA and KDHE, so Kansas Department of Health and Safety. We are a non-regulatory program, and our mission is promoting sustainability through the education venue and also services to industry, institutions, and communities.
One of the programs that we operate here at PPI is the Small Business Environmental Assistance Program. Each state has an SBEEP. K-State simply operates the Kansas SBEEP. And so all these SBEEPs, they're there to provide assistance, education to small businesses that might not have the resources to otherwise understand or come into compliance with some of the rather complicated environmental regulations, such as the Clean Air Act. Here in Kansas, we are multimedia. We assist folks with RCRA hazardous waste regulations, Clean Air Act regulations, like with NESHAPs and with permitting, stormwater, all that good stuff. And we do try and tie in pollution prevention with all the different assistance that we provide. As it is a way to try and reduce the burden of compliance as well. But as mentioned, we do try and focus with small businesses, and in the background requirements for SBEEPs, that happens to be categorized as businesses that employ 100 people or less. Not quite the Small Business Administration's definition of a small business, but just for us, it's 100 employees or less. Key part of it is that it is free and confidential. And if you are looking to identify your own state's SBEEP, you can go to the National SBEEP website and look through the contact lists. All you'd have to look up is literally National SBEAP, and you'll be able to find it.
And the other program that we house inside our institute is the Pollution Prevention Program, or P2 program, in which we provide technical assistance to any size industry. So we don't have that 100 employee limitation. We normally help companies through our internship program. That has been a program part of our yearly activities since 2006. This past summer, we had 10 interns joining our program from a variety of different engineering backgrounds and physical sciences as well. So they work on sustainability projects with their host companies, and they provide some great outcomes and resources that I will talk about it at the end. And we also do workshops, seminars, any sort of educational material with our goal of spreading P2 awareness. So what is going on in our program right now? We were recently awarded 2 new P2 grants from the EPA. We are adding those to our current 3 grants that we have in-house. And under these grants, we have a variety of different projects, but key projects that I would like to briefly mention would be, of course, the internship program. So if you're a host company and you're interested in hosting an intern, make sure you apply now. We have match opportunities available, so we can cover up to 50% of intern costs depending on your industry sector. We are also going to start working on a green brewery initiative, certifying Kansas breweries when they're advancing their sustainability efforts. And we're going to work with them to run a lot of different types of P2 projects. And we're also doing environmental justice community events with the focus of educating the community and industry on what is environmental justice and creating an open dialogue between all parties so we can work together towards a more sustainable Kansas. So our website has much more information on everything that we're doing right now. So feel welcome to check it out. And to start, we always start every almost all presentations when we talk about P2. We prefer making it very clear what we consider to be P2 under our program. So P2 or source reduction is reducing or eliminating waste and pollution at the source. So it's prior from creating it. The whole idea of don't put it in the pipe in the first place. So we have been working with projects doing source reduction or reusing, which in a lot of cases result in reducing the input necessary. For example, when you can reuse a solvent, you need to purchase less of it. So this also falls within our P2 criteria. And we also try to work with initiatives that target what we call the triple bottom line. So activities with P2 will be doing activities that will benefit people, planet, and profit. And our goal is preserving vital resources for Kansas' future, one of our goals. So we have a lot of pressure when it comes to water resources, especially for agriculture and industry. We have energy costs rising, grids are facing a lot of demand. We have some companies in some more remote locations that are having to fight off for some grid demand. So that actually has been stalling some of their growth initiatives. So that's definitely something that we are trying to work with those businesses, making sure that they can increase their efficiency and lower their energy demands. Resource conservation, because that promotes economic stability, protects environmental and public health, resiliency of local industries. We also know again, Western Kansas, when it comes to water, for example, that is a very valuable commodity. And a lot of industry is caring more and more about how can they actually conserve it so that future generations can also benefit from it. And we're also focusing on environmental justice initiatives. So we know that pollution doesn't affect everyone equally. So we have been working with areas of disadvantage effect of pollution. So this is just a picture that I kind of like how it covers a little bit of the different benefits. So for example, if we're reducing a toxic chemical that an industry is utilizing, there's different types of benefits. So for the company, for example, it can help lower regulatory burdens, cut waste generation, improve overall efficiency, which actually translates to cost savings and streamline operations. We have benefits for employees, so that people component. So we create a healthier workplace. Workers are less exposed to potential dangers. So this leads to better health and safety outcomes. And for the environment, if the chemical is not managed properly, it can contaminate waterways through spills, improper disposal, and among other things. Some chemicals are also VOCs or HAPs, so volatile organic compounds or hazardous air pollutants, and they contribute, for example, to ozone and air quality issues. If you reduce their use, we can promote cleaner air and healthier communities, especially for people that live nearby those facilities. And why chemical processors? So P2 programs, they are normally designed to target industries where we can find the greatest environmental and economic impact. So EPA has identified 6 national emphasis areas. and one of them would be chemical manufacturing, processing, and formulation. So this industry is definitely resource intensive. Many processes will be using large amounts of water, energy, for example, for heating, cooling, separation, cleaning processes. So if we can address these inefficiencies in systems, we can offer significant opportunities both for savings and cost savings and environmental savings as well. And of course, another key factor is the extensive use of toxic chemicals. So many of these substances will be posing risk not only to the environment, but to worker safety and community health. So again, under our P2 idea or mentality, we would be focusing on eliminating or substituting those hazardous chemicals at the source. And this is a map from one of EPA's tools. It's called the P2EJ Facility Mapping Tool. And this is a really great resource for us to identify which environmental justice areas or disadvantaged communities that are affected, for example, by larger pollution levels, have local industry in them. That might be contributing to that pollution. So this helps us target our work. So we are not regulatory, we cannot enforce any company to work with us, but this helps us prioritize which company should we focus on first. So it's a really great resource, and there are actually 92 companies in Kansas that are NEA number 2, so a chemical processor that would be in this case located in an EJ or disadvantaged area. So today we will be covering different areas for pollution prevention. We'll focus on energy efficiency, water conservation, and hazardous waste reduction or greener chemistry. And I'm going to be going over some examples, but we have more than 100 case summaries available on our website with some of the projects that we worked with in the past. So feel free to go after the presentation, take a peek at all the other case summaries that we have.
And we'll be talking through a few topics in compliance. Chief among them is air quality and waste. Specifically under air quality, we are talking a bit about national ambient air quality standard permits and then national emission standards for hazardous air pollutants, other known as NAAQS and NESHAP, respectively. And then for waste, we've got RCRA, the Resource Conservation Recovery Act, which governs hazardous waste regulations. And then here in the state of Kansas, we also have something called special waste, which is different from the EPA definition of a special waste. But just bear in mind, this is not necessarily a comprehensive list of all regulations that could be applicable to, the chemical manufacturing industry, and that other states also may have a different regulations than what we'll be covering, as this is more of a focus on Kansas regulations. And of course, when anything is being discussed with compliance, we are not regulatory. It is ultimately the regulator that has the final word on things. So if there are questions, it's always good to make sure you have a regulator's interpretation. So to give some context behind this, the NAAQS and NESHAPs, so NAAQS, that National Ambient Air Quality Standards, essentially what that is doing is trying to ensure that the quality of air across the country is maintained at a good level. And the way that's done is by splitting the country into different sections, and each of those sections are monitored for criteria air pollutants. And businesses within each of those sections are then permitted based off of their potential to emit. So if your potential to emit is quite significant and you could feasibly cause a deterioration of air quality in that section, you'll face greater permitting requirements than if you say if you have a much lower potential to emit. And additionally, if you are trying to open a business in an area that is already exceeding some of the thresholds for the pollution, then you'll face even greater burdens on your permitting requirements to make sure that in an effort to try to bring the ambient air pollution down to acceptable thresholds. So NAAQS, it is predominantly, the compliance is based off of permits. Now for niche apps, this is more focused on, as the name implies, hazardous air pollutants, specifically chemicals that could be causing cancer in urban environments. And there, I believe, is a list of over, I believe, 172 of the things. Um, and essentially, the goal here is that EPA they did quite a bit of research and identified specific industries and specific activities within those industries that are prime emitters of these HAPs. And so your your applicability to a niche app is based off of what kind of industry you're in, what kind of activities you're engaged in, and of course also your potential to emit. But in this case, it's not truly the actual potential to emit so much as it is if you're a major source emitter or an area source, if your potential is quite significant or quite minor. And on that note, the very bottom table there on the right is showing what that threshold is to be a major source versus an area source. And then on that potential to emit, because that's a pretty key component to identifying what kind of permits you are subject to under NAAQS and to identify if you're a major source or an area source. PTE is truly the potential. It's not the actual amount of emissions that you emit. And it is also based off of worst case scenarios. So in this case, it's 24/7, 365 operations, and you cannot account for pollution control devices unless you do in fact already have a permit, and that permit specifies the need to use that pollution control device. Um, and if you are looking to identify your PTE for a facility or process, just note that there are a number of calculators that are out there. The SBEEPs have, national SBEEPs combined have more than, I believe, 20 of the calculators that you can use. And ultimately, it's based off of your emission devices, what is actually emitting some of those criteria air pollutants or hazardous air pollutants, what kind of materials are being used in those emission devices, and of course, the parameters that they're used in. Now, on waste, though, so adding some of that context to waste, we've got, in general, solid waste, anything that you really throw away. And then from there, that waste can be classified as a hazardous waste if it meets certain conditions, or in Kansas, it could be classified as a special waste, once again, if it meets certain conditions. So in this case, special waste is close to hazardous waste in some regards. It could be almost toxic, or it could be ignitable to a degree. It could be something that requires special handling requirements, but doesn't quite meet the definition for something else like hazardous waste does. And to dispose of special waste, you require an actual authorization from the state regulator. And so you have to submit a request, you get an authorization back, and then you have to manage that waste per the authorization. And then from there, if you do have waste that is considered hazardous waste, which is to say if it's a characteristic waste, if it's ignitable, toxic, if it's reactive, if it's corrosive, or if it's generated from certain specific processes and considered list waste, then you have to manage that waste according to your generator category, which is based off the quantity that you generate each month. So you go to the next slide there. That is where you can see what kind of generator category you might be. And facilities in this sector, generally, from my understanding, are large quantity generators. Oh, you're muted.
Thank you. I apologize. So, switching gears a little bit to the pollution prevention side of things, we always start talking on the energy efficiency side of things when it comes to lighting. So, this is something that we are still finding companies that did not implement or haven't implemented LED lights yet. So making that swap to LEDs in combination with occupancy sensors, for example, yields the best results. So again, when we look at all the potential benefits from switching this to this technology, we have energy savings, reduce equipment wear, especially in combination with the occupancy sensors. There's also that component of no mercury. So Jacob will briefly mention some of those benefits when it comes to managing waste of those bulbs. Less maintenance costs and needs. We don't really have to have people going up and replacing those bulbs that often. So there are a lot of different benefits, and making an analogy with that triple bottom line that was mentioned before. So when it comes to profit, for example, when we look at it at one of those projects like the LED project, it yields cost saving to companies, low payback periods, because that's also something that we are noticing. LED lights, for example, they became much cheaper and more affordable recently, more accessible. So we're looking at payback periods sometimes of less than 1 year, depending on what is the current technology that they have, especially if they have those halogen lights or or even incandescent lighting. So the payback comes really fast. We have longer lifespan too. On the planet side of things, we have, of course, less emissions from the electricity conservation. For Kansas, although we have a lot of wind energy, we still have a lot of our energy coming from burning fossil fuels. There's reduced waste from those bulbs. And also on the people side of things, again, less exposure to some of those hazardous materials like mercury. We, in a lot of cases, can significantly improve the lighting of the facility. So we can increase that brightness and create a safer environment for workers. And we also have that lower maintenance hassle. So there's a risk associated with people going up and replacing those bulbs. Sometimes you have to go on a lift or a ladder. So you can reduce that significantly as well. So other areas of energy efficiency include, for example, motors. A lot of chemical processors have different types of motors, and we have been working with companies to implement a variable frequency drive. It really depends on the type of process that you have going on, but this is a technology that adjusts its power consumption based off of what it's actually needed from the process. So it can reduce the energy consumption significantly. It again prolongs equipment lifespan, lower maintenance costs, and also heat too that is generated from some motors. So you can save some money also on cooling costs depending on your facility. We always have, of course, the compressed air systems. I don't think I've ever been to a company here that did not have an air compressor installed. So those audits are very, very important and can help companies save a lot of money and reduce their energy expenditures. Efficiency of these systems are overall very low. So it's definitely a good idea to implement regular audits. We have a picture there of one of our interns using the ultrasonic leak detector. So sometimes those leaks are so small we can't really hear them or feel them. But they are definitely costing you some money. So this is a tool that interns go around at the facility to search and tag for those leaks, and quantify them too, so companies can understand exactly how much these are costing them. Boilers and ovens are also another area of focus, so making sure that they're properly sized for the process. Oversized systems can waste energy, and undersized systems can also be inefficient and increase their wear and tear. So there's a sweet spot in there. Also, when it comes to a lot of these systems may deal with some insulation, so making sure we are not losing heat. Sometimes simple installation will also yield great benefits. Heat recovery, it's also something that some companies have been exploring. Those systems sometimes can be a little bit on the expensive side, but depending again on the specifics of your company and your processes, you can also get some pretty short payback periods in some heat recovery projects. And another area that we're seeing getting more and more attention recently would be solar panels. And this can be implemented by any business, but we did work with a chemical processor this summer that was very interested in solar panels. We did work with a lot of other companies as well. And just to give a little bit of a background on solar panels, so solar panels by default, they are considered an instantaneous system. They they're simpler systems. They would not include a battery. So whatever electricity you can generate, it will be used in real time. So there is a graph on the top right side of the slide. It basically shows the solar generation curve and the load curve. So in this case, for example, the amount of solar power being generated doesn't really meet the amount of energy the industry is utilizing, and that's quite common. And you're also generating sometimes outside of those operating hours. So if your company, let's say, finishes their shift at 2 or 3 p.m., you still have a little bit of sunlight left, especially during the summer. So in a lot of cases, this is a very important component to be considered by companies that are wanting to implement solar panels. So the main goal of a lot of businesses that we worked with is being independent from the grid. But without those batteries, you can't really do that. So a solar panel, if you have a power outage, for example, without a battery backup, your system won't be working. And also Kansas, and I am sure other states have some similar situations, but there's something called net metering. This is a billing mechanism for solar energy system owners. So basically all the excess energy that you produce, let's say outside of those hours, can be fed into the grid back. So this is very helpful, for example, when you don't have a battery, but then you have a cap of how big your system can be to qualify for that net metering option. So for Kansas, for example, they do have some specifics that are considered the max. So we've been working with companies and asking what would be your goal with your solar panel. And again, in some cases, it's just lower their overall energy costs. Sometimes they want to be completely independent from the grid. Again, those systems, they can vary considerably. So they have different efficiency levels, panel types, there are different types of installations. And we've been working in conjunction with actual solar panel vendors to assist companies. We're not experts in the area, but we've been using a tool called PV Watts. So this can help you make a pre-assessment. So for example, you can assess what is the total solar capacity of your facility. Let's say that you're planning on installing something on your roof. You can check what's the area. They have a really nice system that you can use satellite images to estimate the size of your roof and see how much solar energy can you possibly generate. So before you jump into solar panel installations, and that's something we are working with our company partners as well, is taking a good look at what would be their current electricity uses. So if we can reduce the overall consumption first, this will also impact the size of the system that you may need and also your long-term savings. So this is something that we always help companies keep in mind. This also ensures maximum return on investment. So things that we normally do with the company is we start by analyzing electricity bills, trying to see any sort of patterns for energy consumption. We audit the facility, figure out if there's anything that we could do to help improve that consumption, that energy consumption. And then we look into potential solutions to reduce, to become more efficient, reduce that energy consumption. And then we move next to the solar panels. That's probably the best methodology to start with this project. And there are some financial incentives. I know in Kansas we have the REAP grant that can cover up to 50% of implementation costs. There's some limits, so you need to be in a rural area and you need to be considered a small business. So there's some resources. You can check USDA's website or the Small Business Administration website to see if you would qualify. And I strongly recommend, if you're interested, working with an energy program we have here under our institute, under our department, and a partner of us, the Kansas Energy Program, that helps businesses apply for those grants. And we also have the Federal Investment Tax Credit. August 2022, they passed an extension of it. So it's right now 30% for the installation until 2032. There's more information on the Department of Energy's website. And as an example, we had an intern working this summer with a company in Wichita. They have energy bills ranging from 7,500 to 10,000 a month. So they were really interested in implementing solar panels, and they were moving forward with this project. But the capital cost would be about $140,000 to implement that solar panel system, and would result in annual savings of about $32,000 per year. So pretty short payback period. So 4.5 years was the estimated. It would not be covering all their energy consumption, but their goal was to, just start with something. So at least having all their lighting systems covered by solar energy to start with.
So the compliance benefits of some of those energy efficiency projects is really essentially the benefit of reducing PTE. And that is through changing your emission sources, such as your boilers, your ovens, your engines. If you change that equipment, such as by downsizing it or simply replacing it with something that's more efficient, or with something that's electric, then that has a potential to reduce PTE. If it's electric, it completely eliminates PTE from that source. Now, with that said, something that I feel is incredibly important to note is that if you are simply improving your energy usage or reducing energy usage by changing your run times for that equipment, then that is not truly reducing PTE, because PTE is, once again, the potential to emit. It is based off of 24/7, 365 operations. Your equipment is full throttle. So to really get a good reduction of PTE, it does have to be a true change in that equipment. So with that said, if you do make some substantial changes and you're able to reduce your PTE, then, if you reduce your PTE below a permitting threshold, then that's something where you'd want to talk with your regulator and see if you can ease up on some of the requirements there. Additionally, if you go from a major source to an area source, then that is going to impact your applicability to certain NESHAPs. For example, here are a few NESHAPs there with the DD, DDD, JJJ, JJJ, two different boiler NESHAPs. One is for major sources, one is for area sources. So if you're an area source and you go to an area source, then your compliance requirements may be easier. Once again, caveats, devil is in the details. If you are a major source and you go to an area source, then there are certain major source requirements that might still apply, depending on what kind of emissions you are, based off of the major mapped to area source rule. Something else to note is there are a number of exceptions and exclusions within these NESHAPs. So for instance, boilers, I believe the area source boiler NESHAP has an exception for natural gas fired boilers. So if you're changing from a boiler that is subject to the NESHAP to one that is not subject to the NESHAP, then that too is an opportunity to reduce your compliance requirements. When it comes to waste, energy efficiency projects, there aren't necessarily too many projects that we thought through from the P2 perspective, that would also apply to waste regulations, with the exception of lighting. So lighting, and also with the solar panels too. So with lighting, in this case, mercury lamps usually are your fluorescents. Typically, those are considered hazardous waste. And so if you do change to LEDs, then you're reducing the generation of hazardous waste that you have each month, which, if you reduce it far enough, can reduce your generator category to something that's smaller, reducing your compliance burden. However, if you are managing your fluorescent lights as hazardous waste and you cannot currently change to LED lights for whatever reason, then you'll want to manage your lamps, your fluorescent lamps, as universal waste instead of hazardous waste, because universal waste is still a way of reducing your generator category, your monthly generation counts. Something that I want to also mention too actually has to do with solar panels. And this is an emerging topic right now, where solar panels have the potential to be hazardous waste at the end of life. And right now, EPA is in the process of developing some amendments to the universal waste regulations to add solar panels to universal waste, which would allow facilities that do have solar panel waste that is actually hazardous waste, they could follow those universal waste regulations to reduce the count of monthly hazardous waste that they actually have. And if you have batteries associated with the solar panels, typically those are going to be your lithium or lithium ion batteries. Those are presumed to be reactive hazardous waste here in the state of Kansas. Federally, it is thought they would be. Actually, there's an EPA memo that states that they are likely to be ignitable and reactive. And so it's always important to do your due diligence, do your waste determinations, and make sure that if you install a new process, that you know what kind of waste you could be generating from that process.
So switching gears to water conservation, we always need to bring up the basics of reducing use and losses. So, for example, repairing leaks, shutting off processes when not in use. We did have a project with from some interns that were related to implementing a sensor system to stop a wash line when no part was in process. Simple things such as low flow systems, aerators. We've had a lot of interns this summer looking into simple aerators from restrooms at facilities. Simple and pretty cheap to implement, but also results in really nice savings. Tank cover, so anything that could help water evaporation not from happening is definitely another opportunity. So steam traps, so they are very important in systems that use steam, heating, or in heating systems or any other types of processes. So they are removing that condensate air and other gases, while at the same time not letting that steam escape. So we had an intern working on a steam trap project this summer. So he found 21 leaky systems and 7 faulty lift stations. So by fixing those steam traps and those stations, it could help the company reduce almost 15 million gallons of reverse osmosis water. 500,000 kilowatt hours of electricity, and over 500 metric tons of CO2 equivalent emissions. So in this project, for example, savings were estimated of about 71,000 a year. So that's from utilities. Implementation costs about $20,000 and a 0.3 year payback period. So that was a no-brainer for the company, and they are currently implementing this project. And also on the reverse osmosis, those systems, they are filtering water in a lot of industries. You need to have clean water for their processes. So a reverse osmosis is a pretty common type of system that we see at chemical processors and metal fabricators as well. Older systems sometimes can be very inefficient, and in some cases, the recommendation might be to like completely revamp your system, which was also a case from an intern project this summer. So they had a two-stage reverse osmosis unit that had a pretty high rejection rate, so about 18.2%. The equipment was about to become obsolete, so it was not really efficient or reliable anymore, and the company needed to work on an upgrade. So this was a much more expensive project in comparison to just fixing the steam traps, but also resulted in some pretty nice environmental savings, over 3 million gallons of water, 650,000 kilowatt hours, and over 600 metric tons of CO2 equivalent reduced. So for this one, almost 100,000 a year in savings, about 450,000 in capital costs for the whole new system, and about a 5-year payback period. So this is also another project that is in progress or being implemented by the company. And I will show the case summary at the end from the intern and the company, so you can have a better idea of the other projects too.
So compliance benefits from water conservation, for air quality at least, that's going to come from, once again, trying to reduce PTE values and altering applicable NESHAPs through changing equipment. In this case, if your water conservation is on hot water and you reduce the amount of hot water that you are consuming or requiring enough to change your boiler, then that's how you'd be able to get through and reduce that PTE value and potentially alter your applicability to certain NESHAPs. When it comes to waste, so this is coming through in terms of pre-treatment systems. So if your facility has a pre-treatment process, and as a result of your processing, you're generating a number of treatment media waste. And that treatment media waste is either hazardous waste or is a special waste, then by improving your conservation, you could reduce the generation of those wastes and reduce your compliance burdens. With the caveat that that water conservation project is also related to a reduction in the overall pollutant load that is causing that treatment media to become spent in the first place.
And talking a little bit about green chemistry. So the main definition is design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. And in our program, we have been doing a lot of work mostly on the idea of focusing on chemicals that would not become toxic byproducts into the environment. So for the example here, I have switching from chlorinated solvents to aqueous systems, for example, for cleaning and degreasing. We have a lot of metal fabricator partners. So that swap in chemistry has been one of our main focuses in the program. And we understand that green chemistry has tremendous potential to reduce the environmental impacts, but there are also some challenges. It could be, for example, the lack of alternatives. For example, PFAS, it's commonly used in industrial applications and consumer products. They're really hard to replace sometimes or find some substitutes. They are very used in applications like firefighting foams or industrial coatings. So companies are still trying to figure out how to replace this chemical. Sometimes it's hard to make it compatible with your current process. We understand that sometimes, again, it involves some pretty significant investments. You have to retool equipment, you have to modify your processes. So that's definitely something that we see some of those barriers, efficiency and performance gaps too. Sometimes real, and sometimes, people believe that a more environmentally friendly chemical might not work as well or perform as well as the traditional chemical. But sometimes there is definitely some sort of lower performance involved when we're talking about high temperatures, corrosive environments. So there are some challenges with green chemistry, but also a lot of companies doing great work in this field. I wanted to mention a tool called Cleaner Solutions. So this tool is from the Toxics Usage Reduction Institute. So this tool helps you helps you replace a solvent that you currently have in process. So you can look for what is the solvent that you currently have, what is the contaminant, the substrate, and the equipment that you have available. So they have this pretty robust database of all their previous lab testing results. So you can go around and see, well, if I'm using TCE and this is the contaminant I have, it's grease, for example, on an aluminum par, you can check out to see what worked. And this can give you a kickstart in finding an alternative replacement. So we did work, for example, with a company this summer called 3P Processing in Wichita. They are working on replacing their trichloroethylene TCE vapor degreaser system. And the alternative that was found by our intern involves an aqueous system. So it can help them reduce considerably the amount of emissions from that TCE. So again, different alternatives, different companies trying to implement some greener or less toxic chemicals in their processes. In this case, it would involve replacing the equipment as well. But the aqueous system overall is not that expensive. It's actually much easier to manage than TCE. And then we have this other tool also from Tori called P2 Oasis. And this is an interesting tool to help you compare different types of chemicals when it comes to the environmental health and safety attributes. So they have a scoring system, and you can compare, for example, the current chemical that you have and your alternative option. This is an example of of what this tool can generate for you. So here, for example, if we're talking about TCE, it's pretty bad when it comes to health, human health effects, ecological hazards, life cycle factors. And then you can look at the alternatives to see in which areas would you be improving upon. And also, I wanted to mention EPA has a pretty great website when it comes to green chemistry, and they have awards every year for the Green Chemistry Challenge. And this is also a great resource if you're a chemical processor and you're looking into some new ideas and new technologies available. So on their website, you will find a list of the awardees, the company, a summary, so you can have a better idea of what exactly that project is about, the technology and the industry type that was awarded it. So again, promoting good practices and finding some different resources can help you if you're looking into implementing some green chemistry projects.
So as you might imagine, if you reduce your waste, you can also reduce some of your compliance burdens with hazardous waste. But there's also a compliance benefit in air quality. So if you're using certain materials that emit VOCs, that emit those hazardous air pollutants, and you replace those chemicals or you reduce the total amount that's actually needed to be purchased each year, then you are reducing your emissions. You reduce your potential to emit as well. And through that, you once again have the opportunity, the potential to go down in permitting requirements as well as in applicabilities for NESHAPs. In this case, for the NESHAP applicabilities, once again, to go back to that little context, NESHAPs are based off of industry, based off of a major versus area source, and based off of the kinds of processes and materials you use. So if you are a facility that uses a bunch of hazardous air pollutants, and all of a sudden you're able to no longer use hazardous air pollutant containing materials, well, you have no hazardous air pollutants in the first place. So then the whole applicability to NESHAPs, you don't have nearly as much. You might have a reporting requirement, but you don't necessarily have any of the best management practices or recording requirements that you might otherwise be subject to. When it comes to waste, right? So you reduce your hazardous waste, Boom, bam, you can reduce your generation rate, you can reduce your generator category. Reducing your generator category, reduce your compliance burden. So a lot of that comes from changing how you're doing your inventory management, improving your processes with your efficiencies, as well as changing the materials that you might be using to be something that does not even generate a hazardous waste in the first place. Now, something that is important to note, just as you can see with that red bullet there, is that if you do make changes to your processes that could impact uh, the hazardous waste codes associated with your waste, then you need to do another waste determination, right? So a bit of background, how do you know if you have a hazardous waste? You have to do a waste determination on the waste. And so if you have a change that could change that waste code, you need to reassess it to know if you still have a hazardous waste or if you don't. So it's always important to just make sure you document those processes so you can prove it if a regulating agency comes out and does an audit. Um, Otherwise, alongside P2, there are other opportunities to reduce your compliance burden under the Resource Conservation Recovery Act, and that would be to manage your eligible hazardous waste as universal waste, just as mentioned under energy efficiency, right? Your fluorescent lights, that can be managed as universal waste. In the future, potentially, solar panels could be managed as universal waste. Lithium-ion batteries, those can be managed as universal waste. There's a set category of hazardous waste that can be managed as universal waste. So it's always a good idea to take a look at that and assess your waste streams to see what can be managed as universal waste to reduce your compliance burden. The other thing is episodic events. So if you have a major cleanout, if you have a spill or anything along those lines, and you are worried about going up in a generator category, you can apply for an episodic event to keep your current generator category so you don't have to worry about having to follow additional compliance requirements associated with those higher generator categories.
Okay, so to wrap up, I wanted to show real quick. This is the case summary or the summary results from one of our interns this summer from Asif. He worked with Burla Carbon. They are a carbon black manufacturer located in Ulysses, Kansas, so Western Kansas. They are really interested in projects related to water and energy conservation. And Asif worked on a few different types of projects, so compressed air, water conservation from that new system, the new reverse osmosis system, so those steam traps, LED lighting, and a solar panel installation. And the company is actually already implementing all of his projects with estimated environmental reductions of almost 2,000 metric tons of CO2 equivalent and cost savings of about $200,000 per year. They are definitely very worried about water in their area. Water is a very relevant resource for their process. If they don't have water, they cannot produce their carbon black. So they're going the extra mile to make sure that they can be as efficient as possible when it comes to water resources. So pretty nice to see the companies implementing the projects that the intern worked on. So if you're a company and you don't really know how to start, I mean, we gave a few different examples here of potential P2 projects. There's definitely much more than can be done. Our website, like I said, has a lot of resources and different case summaries that can give you some ideas. But you can always contact us. We can do a free evaluation, check your operations, potential projects. You can figure out what would be your priorities. And if you are interested, you can apply to host an intern for the next summer. So applications are due by the end of January, and we are responsible for almost every component of the internship, from hiring, training, placing, and mentoring them throughout the summer. And they can provide you with great deliverables. And so they have that case summary that is published on the website with company consent, but you get a full technical report with a cost analysis for your alternatives and also an environmental impact. So it can help you move forward with your sustainability goals. Or if you don't have any, we can also help you come up with that or kickstart your sustainability goals. So we had two other webinars over the past month. They're both available on our website. So the P2 strategies focused on food and beverage, and then the automotive, aerospace, and metal manufacturing webinar. So they're available on our website. Please reach out if you cannot find those. And that was all that we had for today. We're still have a few minutes available. So if anyone has any questions, I was planning on checking the chat first. There was a question about using EPA P2 grant funds to purchase the leak detector and other equipment. And we do budget for equipment when we apply for those grant funding opportunities. So we do have the air leak detector. I have to say it's a great tool. Almost every intern we have use that tool at some point. Like I said, air compressors are present in almost every company we go to. So definitely a good investment for the program. And the tool lasts a considerable amount of time too. Anyone else has any other questions? Feel free to use the chat or unmute yourself.
Hey, my name is Jenna McWhirter, and I'm with the Tennessee Department of Environment and Conservation. And just wanted to say thank you for doing this presentation. And I actually work in our SBEEP program. And I was wondering if SBEEPs can reach out to the Pollution Prevention Institute to get some assistance if they were interested in something like the green chemistry or trying to reduce their environmental footprint.
Yeah. So if we can definitely help you with resources. So
Mhm.
for example, if you are looking for, oh, have you ever dealt with this sort of chemical in a process? We can help you find those resources. We
Okay.
do have P2 programs at different states. So for example, our P2 program works with companies in Kansas. So, which state did you say you're from?
Tennessee.
Tennessee.
Mhm.
Oh, yeah. Jacob, do you happen to know if Tennessee has a P2 program?
Not
Yes, I actually work kind of
Oh,
closely with them, but yeah.
okay, okay. But no, we can absolutely share, if you have, I don't know if well, there's the NSB. Are you part of that listserv?
Yes. Mhm.
Yeah, because sometimes we use that listserv to ask questions, again, our best thing, I think one of the best things about all these programs is that we can all leverage each other's connections and knowledge. So if you
Absolutely.
ever, feel like, oh, I've been looking for a tool or something, I don't know how to use this tool, feel absolutely free to reach out to us.
Awesome. Cool. Thank you so much.
Yeah. Jacob, do you want to add anything?
Yeah, another really good technical assistance provider is the Iowa Waste Reduction Center.
Okay.
So
Yes.
they're also a really great resource to reach out to you for P2 topics. And I saw that Jessica Dalzell in the chat had also mentioned that if you wanted to discuss some P2 things in Ohio, you could also reach
Mhm.
out to her. But as Chris mentioned, it is a connected system. And
Mhm.
so if you reach out to somebody, ideally they'll be able to, and if they don't know, they'll be able to reach out to
Mhm.
others and try and get you some good information.
Absolutely. I feel like that's how I've understood this program so far. Is just you just gotta ask. So
Yeah,
thank you guys.
someone somewhere worked with this before, So what we always say, we don't try to reinvent the wheel.
Yes.
If we're encountering something different that we've never seen before, the first thing we go and do is ask around, if anyone, and sometimes, we can ask EPA directly. They have a P2 hub resource that is also really nice. So you can ask them directly some questions, and they can also help connect you with another program or a specific resource that can help you. So yeah, we've been using all these to
Awesome.
assist our program.
Great. Thank you guys so much.
Yeah, thank you. Anyone else? If that's if those were all the questions,
There is one in the
Oh.
chat looking for a contact for the P2 Institute.
for
Would you
for
be
the
referring
P2
to
PPI?
for us?
For both, maybe. I'm Rachel Diner. I'm also with Ohio EPA's P2 program, and I'm interested in picking both of your brains a little bit more.
Yeah, I will just put my email in the chat.
Ditto.
But yes, feel free to shoot us an email. Our website has the main email from the program is ksu-ppi at ksu.edu, but you feel free to contact us directly. Yeah, we love that. We also sometimes reach out to programs to brainstorm some ideas, and sometimes go work on collaborations, because that's also something we are always looking for. And I know that different programs like the EPA, they appreciate collaboration too. So yeah, no, absolutely. Please reach out.
Will do. Thanks, y'all.
Thank you. Okay. Well, thank you, everyone. This recording will be of the presentation will be available on our website as well if you want to take a peek back, get some of those links. But I want to thank everyone for joining, and hope you learned something from us today. But again, like we were saying for the past, hour or so, please contact us. We are very much available and interested in learning from other P2 initiatives, and we would love to help too.